Okay, here we are. This is a sample sort of practice test of adding, subtracting, multiplying, dividing integers. And I'm going to work through this sort of problem by problem. But before we start, I'm going to do a quick review of something we've been saying for a number of weeks now. First, about multiplying and dividing integers. A positive times a positive integer will give you a positive integer. A negative integer times a negative integer will give you a positive answer. A positive times a negative is a negative, and a negative times a positive is a negative. The point here is when the signs are the same signs, the product is positive. You have a positive answer. Remember, we're talking about multiplying, dividing. We're not talking about adding, subtracting, just multiplying, dividing. When the signs are different signs, the answer will be negative when you multiply or divide. And we'll work through this as we do some examples here. So that has to do with signs, knowing the signs when you multiply and divide. It's not quite the same when adding and subtracting. The other thing to quickly recall that we've been practicing is that subtraction is the same as adding opposites. So let's look at a couple examples here real quick. So 7 minus 2 on a number line would, if you remember, would that be like starting at 7 and going back 2? And I get 5. 7 minus 2 is 5. But subtraction is adding opposites. So 7 stays the same. The subtraction becomes addition. And what is the opposite of 2? Negative 2. And now we have a problem like we worked with the number lines. So this arrow here represents 7. So here's my 7. And this arrow moving this way represents negative 2. Either way, I end up at 5. Okay, let's get started. So the first problem here is negative 44 minus negative 15. I will go ahead and use my definition again that subtraction is adding opposites. So I can write this as negative 44 plus, so I've changed this. What's the opposite of negative 15? Positive 15. So we had this jingle earlier too that said same signs, add them up, different signs, subtract. All right, take the sign of the higher number. So I have different signs here. So let's subtract them. 44 minus 15. So I'm going to have to borrow. So the answer is 29. And what I need to do is I need to take the sign of the higher number. That is, which number is further from 0? The negative one. So this right here is going to be negative 29. One other way we can look at that is we can break the negative 44 apart into negative 29 plus negative 15. So these two right here combine to negative 44. And I'm going to add my plus 15. And the beauty about this is I have a 0 pair now. Negative 15 and positive 15 is 0. Here's my 0 pair. I'm left with negative 29. Negative 9 minus negative 7 plus 4. Let me do my subtractions adding opposites. So this is what I have for subtraction. That's an adding problem. So this becomes plus, what is the opposite of negative 7? 7. Bring down to 4. 9 plus 7 is 16. 16 plus 4 equals 20. That one was pretty straightforward, I hope. Now we have negative 3 times the quantity negative 5 squared. So the first thing to pay close attention to is this 2 is operating on everything on the inside of the parenthesis. And remember, with PEMDAS, I do with the parentheses first, then the exponents, then I do multiplying, dividing from left to right, then add, subtract. Well, there's nothing inside the parentheses to do in either case, so I can do the exponents. So I have negative 3, and I'm going to write this out now. Negative 5 times negative 5, because I have 2 negative 5s. Now, in this case, I feel like I'm going to sneeze, so excuse me. Maybe not. If I did it from left to right, I would have negative 3 times negative 5 would give me positive 15. And positive 15 times negative 5, negative 75. Of course, I could also see it this way. If I did these two first, negative 5 times negative 5 would be positive 25. And positive 25 times my negative 3 is still going to get me negative 75. Either way. Here, 63 over negative 7, well, it's a fraction. It's a fraction is a division problem. So this is 63 divided by negative 7. Well, I've got a positive divided by a negative, so my answer is definitely going to be negative. 63 divided by 7 is 9. Negative 9 is my answer. When the signs are different, the answer is negative. So here it says rewrite the expression using h equals negative 6 and j equals 7, then simplify. So the first thing I have to do is I have to plug in for my variables. So j is worth 7 minus h is worth negative 6. So if I use my definition again, subtraction is adding opposites. So 7 plus, what's the opposite of negative 6? Positive 6. 7 plus 6, 13. Same thing here, I'm going to have to rewrite the expression. So let me plug in first. So I have, remember when I have a number next to a variable, that means multiply. So I have 2 times k is negative 5 minus m is 7. So there's no exponents, but I have some multiplying, so I need to do this multiplying first. 2 times negative 5 is negative 10, right? Different signs. Answer is negative. So I have negative 10 minus 7. So this here, if I leave it as a subtraction problem, it's going to be negative 17. If I want to rewrite it as an addition problem, just to see that, I would have negative 10 plus, what's the opposite of 7? Negative 7, negative 17. So I owe $10 and I owe another $7. I'm still going to owe $17, negative 17. Moving on. I'll rewrite the expression again. So I have negative a. So negative, that's this. A is 9. So that's going to look like this. Minus b is negative 5. So I'm going to have negative 5 squared. Because the square is operating on b, and b is all of this. So it's critical I do this. So again, I have to do my exponents first. So I have negative 9 minus. So this becomes negative 5 times negative 5. So I have a multiplication problem here. I have negative 9 minus negative 5 times negative 5 is 25. So negative 9 minus 25, negative 34. If I wanted to see this as an addition problem, I have negative 9 plus the opposite of 25, negative 25. Again, the answer would be negative 34. Here I've got g minus 2f, and g is worth negative 3, so I have negative 3 minus 2 times f is negative 7. So here I have this multiplication to do first. 2 times negative 7, so I have negative 3 minus 2 times negative 7 is negative 14. Right? Different signs. And it might help if I cover that up. So I can say I have 2 times negative 7. So different signs, answers me negative. Negative 3 minus negative 14. So let's change this to say negative 3. This becomes addition, and the opposite of negative 14 is 14. Negative 3 plus 14 is going to be 11. Same signs, add them up, different signs, subtract. If I think about that, so I have 14 minus 3 is 11. And the higher, the number furthest from 0 in this case is 14, which is positive. Answer is 11. Write an addition expression to match the number line and arrows. So I have one arrow that's going this way, another one that's going back this direction. The tip is kind of hard to see there. So if I start here, because this starts at 0, I go from 0 to negative 6. That arrow represents negative 6. I'm going to add to it this. So here I go from negative 6 to 0, 6. And do another 6, that's 12. I've gone over one more, so I'm adding to that 13. So this first one is negative 6. This second arrow is worth 13, positive 13, right? It's pointing this way. And this other arrow is pointing back, so it's going to be negative. And it's going back 1, 2, 3, 4, 5. So I have negative 6, plus 13 plus negative 5. So these two together, again, I can think of it as, I'm just doing the first two. Same signs, add them up, different signs, subtract. So I have 13 minus 6 is 7. So this part here is 7 plus negative 5. Stand by, I'm going to fix the light. So it's negative 6, excuse me, let's do this. Negative 6 plus 13. So there's my negative 6 plus my 13 is 7. And sure enough, there I end at 7. Plus negative 5. That's going back. And you can see on the number line, I end up at 2. But I can also do the same thing, you know, same signs, add them up, different signs, subtract. That's my jingle for adding. So I have 7 minus 5 is 2. And I take the sign of the higher number, which is 7, and that's positive. So my answer is 2. And there it is, worked on the number line too. So I end up, my last arrow shows up right there. But you know, it really wouldn't matter which order I did these in. As long as I start at 0, I would still get 2. I can go 13 to the right, and then back 5 and back 6. I'd still be at 2. I can go negative 6, and I can go negative 5, and I go back 13. I'll still end up at 2, which is kind of what this problem's about. Which of the following expressions would give an answer, give a different answer? Ooh, look at that. Let's read it correctly. Give a different answer than the number line below. Well, I can see right now that the answer to this, it starts at 0. It goes over to 5, to negative 3. The answer to this question right here is negative 8. The question is do these match up? So here I have 5. I go back 5, 6, 7, 8. So I go back 8, and I go back further 6. 1, 2, 3, 4, 5. Oh. So here this one was, so actually this is wrong. So that's different than a number line. It looks like I meant to only go back 5, but this is different. So I had that. So let's ignore this one because I didn't create answers here that were, all these answers are going to be wrong because I counted incorrectly. 1, 2, 3, 4, 5. Hope this helps. Remember, when multiplying or dividing, if the signs are the same, the answer is going to be positive. If you have different signs, the answer is going to be negative. Subtraction is adding opposites. So 7 minus 2 can become 7 plus the opposite of 2 is negative 2. And the other thing we did about this was our jingle. And the jingle worked with addition. So if I have jingle, so much for my L. And with the jingle said, you know, same signs, add them up, different signs, subtract. So jingle is for adding. So if I have 13 plus negative 5, same signs, add them up, different signs, subtract. These are different signs. So I go 13 minus 5, which is 8. And I would take the sign of the higher number. That is, this is furthest from 0, and it's positive, so this answer is positive. But it's same signs, add them up, different signs, subtract. So if I had negative 13 plus negative 5, they're the same sign. I would simply add up 13 and 5, which is 18, and I'd keep the sign. It's not a very mathematical jingle, but it works. It does work. But that jingle is only for adding. So you can take your subtraction, change it to adding, and then use the jingle. Hope this helps.